Okay. Good afternoon, everyone. Thank you so much for joining us. I'm actually going to walk the stage a little bit because I feel awkward when I'm standing behind the podium. But if I look awkward walking, don't judge me too much. I was told not to turn to the side, so I'm going to walk a little bit like this, and we're all going to just pretend it's very, very normal. So thank you again for joining us. It's a Thursday afternoon. I'm so glad that you are all here. Now that we're here, we're family. I'll treat you all like my family, which means I'm about to disappoint you. So, why does gaming lead the AI race? And what can we learn from the world's most data-driven industry? So for those of you who don't know me, my name is Carly Taylor. I'm a lifelong gamer. I've been gaming since I was very, very young. I started with the Lion King platformer game when I was about 5, which taught me that life is not fair and you don't win at everything you do, because that game was really, really, really hard. I don't know if anyone played it, but I still have nightmares about it. I'm also an engineer. I'm a classically trained chemist. I transitioned into tech, where I started as a data scientist. Then I became a machine learning engineer, and now I build high-performance engineering teams. I worked on Call of Duty for about 5 years, doing live operations, everything from online networking to security. Really kind of the whole tech stack there. And I'm also a LinkedIn lunatic, which those of you who follow me on LinkedIn might know what that means. Those of you who don't start. You don't want to get into it. It's not worth it. So, getting started today. I'm about to say some things that some people might not agree with, but I think that it's true. Jack McCauley said this best: without video games, there would not be AI. It's hard to prove a counterfactual, but I think AI, in the way that we think about it today and the way that we're experiencing it, absolutely would not exist without gaming and gamers driving the adoption of consumer-grade GPUs and also laying the infrastructure that we think about today for training AI. So, I've said AI, 10,000 times already in this conversation. You've heard it for the millionth time today. But let's level set before I move on and talk about what I mean when I say AI. So, what AI actually is a field of computer science dating back to the 1950s. It's really concerned with building machines that can emulate human decision-making, right? So this has been a thing for a very long time. Things like pathfinding algorithms, and we'll go into that a little bit more later. But when people say AI, what do they think it is? When we say AI colloquially, we think of generative AI, using large language models and diffusion models to generate things that humans would otherwise generate, this process of creation. I'll talk about all of these things listed here today, including machine learning and deep learning, but I think it's worth going through the fact that AI as a discipline has been around for a very long time and is in fact nothing new. So, the way I see it, the recipe for AI, what we needed in order to get to the place that we're at today, were 3 things. We needed scalable infrastructure, right? Like I said earlier, the computing power and the interconnected systems that were needed to train these large language models efficiently. Number 2, we needed the modern architectures in order to actually build these things, right? These breakthrough neural network designs that enable these generative capabilities. And finally, all the data, right? The great scraping of the internet has happened. All the data humans have ever put out has been put into these machines, and they need more and more and more and more and more, and it's a constantly ongoing problem. So for today, I'm going to talk about the first thing, the scalable infrastructure required to create AI. So we're going to go through some computing power slides. We're going to dig into some history, so we'll ask you all to not get too excited, and then we'll get into some lessons. All right, back to 1996. Does anyone here remember a game called Roller Coaster Tycoon? Great, great, great game. I love this. Gamers in the audience. Gen Z calls this time period the late 1900s, and I hate it very, very much. But 1996, I was also playing Roller Coaster. Actually, 97, I guess. It was launched in 96. Roller Coaster Tycoon. This is a game that was written entirely by one man, Chris Sawyer, in x86 assembly, which any of the nerds in the audience, I think I can actually pick all of you out right now who know anything about programming language, understand that x86 assembly is a hard language to write in. You wouldn't choose it if you were firing on all cylinders. But what's interesting about this is that the computing power at the time for the game that Chris wanted to create, right? Chris wanted this immersive world with little people that ran around, and you could trap them on roller coasters and they would get upset because they had this thought process, right? And they would react to the things you did in your park. And he wanted to build this immersive world, but the computing power at the time was akin to like a TI-86 calculator today. So how did he do it? He couldn't write in a compiled language like C because it wasn't performant enough. And so he said, well, instead of giving up on my dream, I'm going to write this in machine code so that I can optimize the shit out of it and make it actually work to what I wanted. Now, I've heard a story about Chris back in the day. He's after, the success of Roller Coaster Tycoon, the IP took off. They ended up wanting to port this game a few years later to console so people could, more people could play it. And he said that it took a team of developers writing in C++ longer to write the ported version of Roller Coaster Tycoon for console than it took him to write it originally in x86 assembly by himself. So if you want to go fast, go alone, and if you want to go fast, be Chris Sawyer because you're really smart. So interesting time, right? What happened after this? Well, a couple years later, a little company called NVIDIA had seen this challenge, right? CPUs were not built to do the kinds of massive parallel calculations needed in order to handle rendering 3D images and the things that computer graphics needed in order to support video games. So the GeForce 256, 25 years ago last year was the anniversary of the GeForce 256, the first ever GPU. Now, at the time, this was overlooked by all but the most niche tech nerds and gamers, right? It wasn't really released to a huge amount of fanfare. But what's interesting is that NVIDIA had this idea, right? They looked at the CPUs and they said, these are not purpose-built for the things we want to do. We need something different. The year is now 2000, a year later. Now, I'm not going to sit here and tell you this was the first time anyone ever thought of interconnected computing systems or the first time the cloud was ideated on. But what I'm going to tell you is that I distinctly remember this. Back in the early 2000s, there was a little system called folding at home. And those of you who are gamers might remember, on your PS3 and on your PC before that, you could lend your GPU, because now they were being widely used, for this project out of Stanford that helped with protein folding, right? They were doing these massive calculations to solve problems like Alzheimer's. And protein folding was extremely computationally expensive, and they didn't have the hardware themselves in order to do it. So they thought, well, what if we networked all of these consumer-grade GPUs together while people weren't playing their games and used that in order to run these calculations? What a crazy idea, right? Interesting. And what's funny is there was an interface when you ran this on your PS3 or on your PC, and you could see yourself as part of this larger interconnected network of people doing things, running calculations together, right? Really interesting, something that I had certainly never thought of before. I was on the internet, but I was spending most of my time in AOL chat rooms that my parents probably didn't know about or they wouldn't have let me in there. But I wasn't really thinking about the internet in this way, right? Fast forward, yada, 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 20 years, there's nothing interesting happening. Obviously, I'm lying because a ton of interesting stuff happened to help AI along this journey, right? But thinking to 2019, I did want to highlight this because it's an interesting thing that happened. A hackathon project out of BYU gained some notoriety. It was called AI Dungeon 2. And I'd say that this is the first widely recognized video game to be built entirely off of generative AI capabilities. So as we think of what is the future of AI in games, right? We're building immersive worlds. Well, to me, the natural progression of this is that each of us gets our own world. Anything that you do creates the world around you as you're playing it, and the game is fully generative as you are putting in your inputs and it's creating around what you want. AI Dungeon 2 was the first one to do this. Now, funnily enough, the blog post written about this hackathon project and the subsequent adoption of it, and it became extremely popular and had tons of downloads, and it literally just ran out of a Google Colab notebook. The authors actually called this AI Dungeon 2, or How to Spend $50,000 on GCP. So they were certainly not expecting it to be as popular as it is, but I highlight it only because we're still not there yet in a commercial aspect. I don't think we have any large-scale commercial, certainly no AAA games, that are really able to leverage this technology, but we're on our way there. All right, history lesson is almost over, but I am going to make you look at a graph, so bear with me for just 1 second. This is the last time we'll talk about this. Here I want you to see the computational performance per dollar of a consumer-grade GPU over time. And what you're going to see here, and the axes are really small, so you'll have to trust me. I don't know if you should, but you have to. Regardless of the fact that GPU prices are actually kind of getting more expensive, the truth of the matter is that per flop floating point operation, they're actually getting cheaper, and they've been getting significantly cheaper over time. They've also been getting significantly more performant, outdoing Moore's law that says, any transistor should only double in speed every year. Call it Huang's law after Jensen, because GPUs have actually been getting significantly more performant based on what we would guess, and they're getting significantly cheaper. So although a data center grade GPU now, I think the Blackwell architecture from last year from NVIDIA, will run you about $70,000. The amount that you're spending per floating point operation calculation is significantly less. And I'd say that this curve, over time since the early 90s, is driven almost entirely by consumer demand for GPUs, making it cheaper and cheaper and cheaper to do the kinds of calculations we want to do. All right, let's get back to our little nested diagram, because I made this in Canva and it took me a long time, and I want you guys to keep looking at it. I want to talk about AI in games. So, traditional game AI, we've spent a lot of time talking about this. This is the AI of Roller Coaster Tycoon or Mario, right? These are deterministic techniques like finite state machines and pathfinding algorithms. There's no real AI as we think of it today, but still, technically AI has been happening for about 20 years. Machine learning. We all know what machine learning is, right? No one talks about it anymore. It's kind of like we forgot about machine learning. I didn't, but you all did. No one wants to talk about machine learning anymore. Machine learning is the most popular AI used in video games today. It's because inference is extraordinarily cheap. Training these models is very easy. They're not black boxes, and they're very easy to implement. So machine learning is widely used in gaming companies today. These statistical models like decision trees and regression, you use clustering to predict player behavior, all over the tech stack. Next is deep learning. This used to be the darling of the tech community. We'd all talk about neural networks and CNNs, and it was amazing. Not anymore. We've forgotten that it exists. Deep learning is also used a lot in gaming, specifically for running large-scale recommendation engines and things like game stores. And finally, Gen AI. I would say that the adoption for full-scale Gen AI, especially in a consumer-facing category, is not very widely adopted in games at all. I don't think many players see the generative AI being used in video games, and that's on purpose. Number one, gamers don't like Gen AI. It feels like slop. We don't want it. We like the creativity of our games. We like knowing that a person made them. We like the Chris Sawyers of the world, right? We don't want some computer just generating crap for us, and I agree with that. Number two, it's expensive. One thing you might not know is that game servers for online games don't have GPUs. They don't need them because they're not rendering anything, because they don't have people sitting there and looking at the game. They just need CPUs. So you can't run inference on a game server, so there's a technical problem here that we need to still figure out. But Gen AI, like in all industries for gaming, is still used by people building, doing searches for in-game assets, helping make developers' lives easier, maybe helping with some tooling and things like that on the back end. Now, in this case, I will say I absolutely agree with Phil Spencer. All of those things I ran through are probably things you haven't really thought of. And why is that? Because when you play a game, you're not playing the game to sit there and think about, the regression and the clustering and all the stuff that's happening on the back end. All the tech of a game doesn't really matter, right? It does matter if you're kind of nerdy, but in the end, games are not built to showcase technology, right? Technology helps showcase the creativity of a game. And that's always what we do first. We put creativity first. So in technology is in service of a greater goal. I'm running a bit short on time, so I'm not going to go through all these. You guys can breathe a sigh of relief because there's a lot here. But the tech stack for building a video game is quite extensive. You have game engine and world simulation. You're writing things in C++ in order to do the physics and the rendering of the game. You have things like cross-platform experience. You have to have all these platforms talking to each other. The server has to maintain the game state for fair play and authority and handle communication between at least hundreds of connected clients. You have things like online networking, all of which I have learned against my will. Latency, concurrency, and scalability, things like patch handling, making sure every person is playing the latest update of the game, and that they all have access to the skins that they want because you want to play with the latest banana character, and you want everyone to know that you have the latest banana character. We have things like asset pipelines, continuous integration, continuous development for all of the thousands and thousands of developers that are pushing code into the same repository at once. You have platform management. And in the data stack, my favorite part, you have real-time telemetry. Again, you're doing all of the AI things we talked about, personalization, player insights, yada, yada, yada. So, and throughout, AI is woven into every part of this tech stack, right? So why does gaming lead the AI race? Well, by my estimation, I'd say gaming leads the AI race because AI has always been part of the invisible scaffolding that is behind building immersive worlds. It's been integrated into game development for as long as games have been around, but it has never been the main star of the show because that's not what it's about. It's about keeping people engaged and keeping players happy. So how can we avoid hype in AI? Well, you can only find peace by avoiding hype. This is definitely a real quote that I found online. I want to talk a little bit about how I think about hype so that you guys can all get converted and think everything is bullshit as well. All right. I made this quadrant. Gartner, you cannot have it, but you can look at it. On the left are ideas, from good ideas to bad ideas, and on the bottom, you'll see the technological ease of implementation from impossible to possible. So where are we going to start? I think the bottom left quadrant, because I see a lot of ideas living down here. I'm going to call this the why with 4 question marks quadrant, or really the smooth brain quadrant. This is where bad ideas meet technological impossibility. I do see some people hanging out in here, and you don't want to be down there with them. No solution down there is ever going to make it to market, but they probably will get a couple million in VC funding before anyone realizes it. Next up, we have ideas that are possible, but the idea is bad. So this is the we could, but we won't quadrant. This reminds me of the quote from Ian Malcolm from Jurassic Park. Your scientists spent so long trying to decide whether or not they could, they never stopped to think if they should. These are things we shouldn't do. We could, but we won't. I actually see a lot of this in the game development space. This is the ideas are cheap quadrant. These are good ideas that are technologically impossible. And that's because everyone has an idea, but not everyone understands technology. Ideas are extremely cheap, especially in game development. People think, oh, why don't you just do X? And X is something that's physically impossible, given the limitations of literally everything in the world and the laws of physics. So, great idea, but it's never going to happen. And then when you push back, they say, well, actually, I'm in the market for a founding technical CTO. It's like, of course you are. All right, and now where do we want to hang out? Where good ideas meet technological possibility. This is not the majority of ideas that I see, but this is the now we're talking quadrant. It's where you want to hang out. Unfortunately, all the neighbors are shitty, so assuming an even distribution of ideas, I guess I would say that 3/4 of the ideas I see in the AI space are not very good. So what does that mean? That means 75% of everything is hype. So welcome to the cynical version of my mind. You can stay here as long as you want. Let's get to some lessons, because that's why we're all here, right? Lesson number 1. Stop showcasing technology without a larger purpose for what you're trying to do. You are not building AI just to build AI just to say that you built AI. What is the point of that? That's been done. No one's excited about it anymore. You don't just have AI in your product to say you have AI in your product, right? AI or any other technology that's exciting and new should be a scaffolding on which you are building and selling the actual idea that you have. And if you don't have an actual idea, you need to figure out where in the hype quadrant you are and hopefully get yourself out of the smooth brain quadrant. Number 2, trust takes years to build and seconds to lose. Right? We're all implementing this technology at a speed that we cannot possibly even be thinking about the security implications of which I hear very few people talking about this, in fact. Things like we just discussed earlier, right? Servers don't have GPUs. So if you want to run any sort of inference, what would you do naturally? You might think, well, we'll just run it on the consumer's hardware. They have a GPU. Why can't we just offload that calculation to their machine like we do the rendering part of this, right? Because you can't trust them, people. There are hackers out there. There are hackers in here. They're everywhere. You can't trust a user's machine with anything. You ship your proprietary model weights to someone's hardware, what are they going to do? They're going to get them out. And you just spent millions of dollars training a model, and now you leaked your model weights. Congratulations. You got played. So keep your trust. Don't build tech just to say you built it. And finally, avoid hype. at all costs. It might feel tempting. You want to say, oh, we put the AI, I went to Big Data London and I learned about this thing from this vendor and so we bought it and it's going to change the world. It might. Yeah, it might. Who knows? Have you done your due diligence? Have you thought about it? I don't know. Probably not. All right. Are we all feeling really happy? I have about 10 minutes for questions.
Sure. So where does a game like No Man's Sky fit in to the use of AI in gaming, for example? 'Cause that's generative in a way, right? The levels and stuff.
Sorry, what was the question?
So the game No Man's Sky.
The game what?
No Man's Sky.
Yeah.
That has generative levels and things like that. So where does that fit into your, I guess, picture of games and things like that?
I haven't played it yet. How does it, does it work well?
Yeah, so it essentially just is trying to generate sort of worlds and things like that for you to visit and do stuff on.
Do they do the generation, I guess, prior to you playing, or is it kind of on the fly as you're going through?
I think it's on the fly as you're going through.
Interesting. I'd be interested to see how they're doing that.
I said I'm not entirely sure how they're doing that, right? That's kind of my question.
Where do you get it? Is it on Steam?
Yeah.
Okay. So it's running, I wonder if it's running locally or not.
No idea.
Do you have to connect to a server to play it, or is it like a single player?
I think you have to connect to a server.
Okay, yeah, interesting. Do you know the developer?
I could find out, I guess.
Yeah, let's talk afterward. I'd love to hear about it.
When it comes to online gaming, like cloud gaming, one of the least good points about that is gamer toxicity. Is there anything that AI could do to try and cut down on this or flag this so action can be taken against malicious players more quickly?
Oh, 100%. Yeah, so I'd say toxicity in games probably encompasses maybe 3 areas. We have toxicity in the traditional sense of like bullying, grooming, things like that. I'd say anti-cheat also falls into toxic behavior, which is cheating, hacking into the game client. And then I'd also say fraud. So things like gifting fraud or maybe gold farming, if there's an in-game economy, all kind of fall into this umbrella. And yes, AI is heavily leveraged in all areas of that stack. So in terms of like toxicity, there are a bunch of vendors and also gaming companies rolling their own sentiment analysis models. So historically, this was difficult with gamers, right? Because anyone who plays video games know, like, we have our own language for how we speak to one another and like leet speak and things like that make it actually kind of a challenging moderation problem if you think about moderation in the traditional like have a dictionary of flagged words sense, right? People get around that. And then there's also, again, this like gamer mindset. If you're playing with your friends and you guys like to give each other a hard time, is that toxic? I'd say that toxicity in and of itself is a very relative feeling. Like my friends and I tell each other that we have no thumbs and we're terrible at games, right? Like, is that toxic? Maybe, but to each other, that's kind of just how we are. So I'd say LLMs are making this easier because they can handle context a lot better. But then again, at that point, you're limited by the speed at which you can infer and the amount of context you can take. So it's definitely a problem that's getting solved, and I think it's getting better. But there are missteps that happen as well. I think I heard of something really recently. Actually, there was someone got banned, like a big streamer from a popular game, for calling someone else a noob. And it's like, I guess we could get into a debate about whether or not that's like a nice thing to say. Probably not. But like, is it toxic? Is it bannable? There's a lot of policy decisions that need to be made here as well. So like whether an LLM says, this is kind of a sus thing, it's like, then what do you do with that information? Specifically with toxicity, I have seen a lot, probably I'd say from the last figures I heard, maybe 60% of people who are going to be toxic in a game, and I think this is probably true for other online spaces, can be redirected if prompted before they send a message. So this doesn't work with chat, obviously, but if you're going to type something out and it flags it and says, do you really want to send that? About 60% of people will edit their message and not send it. So I'd say it's a space where punitive measures should probably be on an escalating, sliding scale, and then it should be taken into account whether someone is in a public area where the norms are quite different than in private chat where norms might be a little bit different. Does that answer your question? Cool.
Love your t-shirt, first of
Oh,
all.
thank you.
In terms of LLMs that we spoke, it's all coming towards agentic AI, bit LLMs, byte LLMs, I don't know the way to say it. What would you say the future of gaming is? Like, we've been leaders so far, that's established, but what's the future looking like 20, 30 years, maybe even 10 years down the line?
It's interesting. I think gaming's at an inflection point right now, right? There is a push and pull into what people want. So I see so I've been talking about this actually with a couple friends over the last few days. There's this divergence in gaming culture right now where I'd say that the West, gaming studios in the West are very data driven. Gaming studios in like Japan, which is like the mecca, right, for video games, are not very data driven. And there are pros and cons to each. But I think anyone who's a hardcore gamer can say that at the bare minimum, what Japan has managed to do is maintain the creative identity of the games that they're putting out, right? And this is by taking a stance of, we're not going to make everything data-driven. We're not going to put agentic AI into everything. We're not going to storm the beaches at Normandy and be the first there to try to create something crazy. We're going to really still put the creativity first. And as a data person, I feel conflicted about that because I see optimizations that can be made in these games, right? But at the same time, I'd say I really respect the fact that they're staying true to the DNA of gaming, which is a human-first creativity, storytelling, world building. And as a content creator as well, what I'll say is that when I'm reading something or interacting with something and I can tell that it was not made by a person, I kind of immediately check out. Because I've almost trained my brain that I don't necessarily care for the opinion of a machine over the opinion of a human. And I feel like we might get to that place in games where, while a novelty, it might be that we only want the game that was written by Chris Sawyer by himself in his basement because we know the blood, sweat, and tears that went into it. So for the future of games, I don't know. I think that there is a world where we have these completely immersive worlds, a metaverse, so to speak, or whatever we want to call it, and people are loving it and using it. But I don't think that it will ever exist in absence of video games that were written by people and rooms full of artists staying up whiteboarding until 3 in the morning. I personally would be sad to see that go anyway. But I think that we're at a reckoning, right, where Western game studios need to decide, like, how much do you want to invest in this? And is that the play? Because we are already pretty far down the data-driven rabbit hole anyway. Or do we pull back and focus on the creativity? I don't know. And there's friction between the Japanese and Western studios because of it, because it's a fundamental disagreement in how to approach game development. It's a great question. Yeah, I think right here.
Thank you. The gaming industry is clearly using technology to its frontier and using the most that is out there. This obviously is very expensive. Not a lot of people have done it before. So how do you go back to your boards and investors and get them to buy in and spend that kind of money for something that may or may not work? Do you follow the same framework as that matrix?
Well, luckily, I've never actually had to ask for money for a game. What I will say might or might not answer your question. I have friends and colleagues that I have people who are working on about 4 unreleased games from all around the United States, and I'd say 3 out of them just got canceled. Games are becoming, that graph I showed with all the technology in the stack, right? Games are becoming increasingly expensive to make. AAA game can cost $500 million to put out the door, right? And we're talking up to 10 years of development. And the risk of cancellation is high because these studios, they go over budget and they go over time, and they don't have a work product to show for it at the end of the day. And so it's an interesting question. I think that it's going to be a push and pull, and it's going to be whether or not the investment is worth it, right? But I will say the gaming industry every year makes more money than Hollywood and the music industry combined, and most people don't know that, but it is huge, right? So the revenue is there, but the investment is the upfront cost is extremely high for at least a AAA game. Indies have it a little bit easier, but then they don't have the pipeline and audience and marketing capabilities that a huge studio does. So your potential player base is small unless you go viral, so it's a risk.
Do you think there's a difference in adoption and risk between PC console and mobile games?
Oh, yes. There's a huge difference in just the development process for mobile games. Mobile games are very, very interesting in that, I mean, everyone in every industry in entertainment is fighting for attention, right? This is an attention economy where attention is worth money. But the idea is on your console or on your PC, right, you maybe are not fighting for someone's attention as much as you are on their phone, because their phone is where they do everything. And you're playing a game on your phone and, oh, you get a text from somebody, or, oh, you want to open Instagram, right? The urge is so prescient there to just constantly get away from the game that the way that they think about attention and the way that they think about keeping attention and the way that they think about monetization and the way that they think about engagement is so fundamentally different than other games. And also the technology in mobile games is still, while our phones are extraordinarily fast, right, like it's not at the same level of like an actual like AAA game that's running on like a, you know, like your awesome NVIDIA GPU, right? Like you just don't have it there. So the mechanics are extraordinarily different. So I'd say that of the gaming studios, mobile studios are absolutely always the most data driven. When I worked at COD, like I would call King, you know, like Candy Crush people, like they had it locked down. If I needed a churn model, like you talk to those people because they know, they understand, like as soon as someone's losing attention, they have it figured out. Great question. And I'm over time, so we have to go. I'll hang out outside if we want to talk more. Thank you.